A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Chroma just dropped Context1, and honestly, it feels like they're trying to invent a whole new category of software. It's not just a new model, and it's definitely not just a database update. It's an agent that searches, reasons, and retrieves in a continuous loop, rather than a static database that just sits there waiting for you to throw a query at it. Today's prompt from Daniel is about exactly that. He's asking whether Context1 is an agent or a language model, and what makes it so different from the tools we've been using for the last few years.
It's a great question from Daniel, and I think the confusion is actually the point. We're seeing a massive shift right now in how we handle information retrieval. For a long time, we've relied on RAG retrieval, augmented generation, where you take a query, find some chunks in a vector database, and shove them into a prompt, but we've hit a wall with that. Context1 is Chroma's attempt to break through that wall by creating what they call a multi-step search agent. By the way, Corn, before we dive into the weeds, I should mention that today's episode is powered by Google Gemini 3 Flash.
Oh, nice. A little meta-commentary for the listeners. So, Herman, let's get into this. Is it a model or an agent debate? Because if I look at the specs, it's a 20 billion parameter model. That sounds like a language model to me. But Chroma is calling it a search agent. Is this just marketing fluff? Or is there a functional difference in how this thing actually lives in a stack?
It's both, but the functional difference is what matters. It's a 20 billion parameter model that has been specifically trained to act as a retrieval subagent. Think of it as a specialized scout. If you're using a massive frontier model like GPT 5.4 or the latest Claude, those are your generals. They do the heavy lifting, the final reasoning, and the prose generation. Context1 is the scout you send out into the woods to find the specific intel the general needs. It doesn't want to answer your question directly, it wants to find the perfect set of supporting documents and hand them off.
So, it's a hybrid. It's a model that's been lobotomized for general conversation, but hyper-optimized for the task of searching. I like that. It reminds me of how we used to have specialized math coprocessors back in the day. Instead of making the main CPU do everything, you had a dedicated chip for floating point arithmetic. Context1 is basically a Retrieval Coprocessor for your LLM stack.
That's a very fair way to look at it. And the reason we need this right now is because traditional RAG is failing on complex queries. If you ask a standard RAG system a simple question like, "What is the capital of France?" it works fine. But if you ask it something multi-hop like, "Compare the economic recovery strategies of the 2008 financial crisis versus the 2020 pandemic in terms of their impact on middle-class housing affordability," a single retrieval step is going to give you a mess of semi-relevant articles that don't actually connect the dots.
Right, because the 2008 chunks and the 2020 chunks might be in completely different neighborhoods of your vector space. If you just pull the top 5 results for that whole long sentence, you might get 3 articles about 2008 and 2 about 2020, but none of them are talking about the specific comparison points you need. You're essentially asking the final LLM to do a lot of heavy lifting with incomplete or disjointed data.
Well, not exactly. I mean, you're hitting on the core limitation. What Context1 does is fundamentally different. It uses a multi-step search loop. Instead of query, retrieve, generate, it does query, retrieve, reason, refine, retrieve, generate. It can take up to 8 hops to gather information. It looks at the first set of results, realizes it's missing a specific piece of the puzzle, writes a new internal query to find that specific piece, and keeps going until it has a coherent picture.
That sounds like it would be incredibly slow. If I have to wait for 8 rounds of inference before I even get to my final answer, isn't that going to kill the user experience? We're already complaining about the latency of frontier models. Adding a 20 billion parameter scout that runs 8 times feels like a recipe for a 5-minute wait time.
You'd think so, but that's where the optimization comes in. Chroma is claiming this is 10 times faster and 25 times cheaper than using a frontier model like GPT 5.4 for the same iterative search task. Because it's only 20 billion parameters and specialized for this one loop, they've stripped out the overhead. It's not checking its moral alignment or trying to be poetic, it's just executing a search trace.
Okay, I want to dig into this reasoning trace concept. How does a model actually decide what it needs next? When we talk about agents, we usually talk about tool use or function calling. Is Context1 calling a tool, or is it just talking to the database?
It's essentially treating the vector database as its only tool, but it's doing so with a very specific internal logic. It generates what looks like a thought process. It says, I have the data on 2008 housing, but I don't have the specific inflation-adjusted metrics for 2021. I need to search for 2021 middle-class housing inflation adjusted. It then executes that search. The self-editing part is also fascinating. It can actually look at the chunks it has already retrieved and decide to discard them if they turn out to be red herrings.
That's a huge deal. One of the biggest problems with RAG is context pollution. You retrieve 10 chunks, 8 of them are great, but 2 of them are just slightly off topic and they end up confusing the final model. If Context1 is acting as a filter or an editor before the data ever reaches the general model, that's a massive win for accuracy. It's like having a research assistant who actually reads the papers before putting them on your desk, rather than just dumping a pile of books in front of you.
It really is, and it addresses the lost in the middle problem that we've talked about before. Even with million token context windows, models still struggle to pay attention to information buried in the middle of a long prompt. By being highly selective about what actually makes the cut into the final context window, Context1 ensures that the downstream model is only looking at high signal information.
It's interesting that they went with 20 billion parameters. That's a bit of a Goldilocks size. It's large enough to have some genuine reasoning capability. You can't really do multi-hop logic with a 3 billion parameter model, but it's small enough to run on relatively modest hardware or be served very cheaply in a serverless environment like Modal.
It's a very strategic choice. They trained it on over 8,000 synthetically generated tasks to specifically handle these retrieval loops. This wasn't just a general purpose model they fine-tuned on a few examples. It was built from the ground up to understand the relationship between a query and a document corpus. They're calling it agentic search, and I think that's the right term. It's moving from a passive index to an active investigator.
Let's talk about the ecosystem implications for a second. If I'm a developer and I've spent the last year building complex LangChain or Llama index pipelines to do this kind of iterative retrieval, writing my own loops, managing my own agentic state, does Context1 just make all that code redundant?
In many cases, yes. A lot of the spaghetti code in current AI applications is there to handle exactly what Context1 does natively. Developers are essentially trying to build a brain for their database using wrappers. Chroma is saying, what if the brain was part of the retrieval engine itself? It simplifies the orchestration layer significantly. You send a complex query to Context1, and it returns a clean, edited, ranked set of documents. You don't have to manage the state of the search hops yourself.
I can see a lot of people being skeptical about the cheaper claim. Even if the model is smaller, if it's running 8 times, that's still a lot of compute. But I suppose if the alternative is asking a trillion parameter model to do that same iterative thinking, the math starts to favor the specialized model pretty quickly. It's the difference between hiring a specialist for $50 an hour or a general consultant for $500 an hour. Even if the specialist takes twice as long, you're still saving a ton of money.
And it's not just about cost, it's about performance. Frontier models are generalists. They are amazing at many things, but they aren't necessarily the best at the boring work of document retrieval and filtering. There's some research suggesting that specialized models can actually outperform the giants on narrow tasks because they don't have the noise of all that other training data. Context1 doesn't know how to write a sonnet about a toaster, and that's why it's better at finding you legal documents.
I'm glad it doesn't know how to write toaster sonnets. We have enough of those. But let's look at a practical example. Let's say I'm a lawyer, or I'm building a tool for a legal research firm. This is the classic high-stakes RAG use case. How does Context1 handle a query like, find all cases in the Ninth Circuit from the last 5 years that mention both trade secret misappropriation and the use of generative AI, but specifically excluding cases involving social media companies?
That's a perfect candidate for Context1. A standard vector search would probably get tripped up by social media companies and generative AI and just return a bunch of stuff about TikTok or OpenAI. Context1 would start by searching for the core concepts. It would find some cases, realize some of them involve Meta or Snap, and then it would see your excluding instruction. It would then reason, I need to filter these results or find cases that explicitly deal with other industries. It might perform a second hop to look for generative AI trade secrets manufacturing or generative AI trade secrets pharmaceuticals to see what else is out there. It's simulating the way a human junior associate would actually use a search engine, trying a query, seeing it's too broad, and then narrowing it down.
That junior associate analogy is one I'll allow you this once, even though we try to avoid them. It really does capture the iterative nature of the work. It's not a one-and-done interaction. It's a conversation between the model and the data.
And what's wild is the self-editing part. If it finds a document that looks relevant, but the specific chunk it retrieved is missing context, like it's the middle of a paragraph that refers to a previously mentioned statute, Context1 can actually recognize that and go back to the database to say, give me the full text of this document or give me the preceding 3 chunks. It's managing its own context window to make sure it's not handing off half-baked information.
That solves a huge headache for developers. We've all spent hours tweaking chunk sizes. Is 500 tokens better than 1,000? Do we need a 200 token overlap? Context1 basically makes chunking strategy less critical because the model can just ask for more if it needs it. It's a dynamic window rather than a static one.
It shifts the burden of finding the right information from the developer's pre-processing pipeline to the model's runtime reasoning. That's a fundamental shift in AI architecture. We're moving from data engineering for AI to inference engineering.
I want to talk about the multi-hop aspect a bit more. We've seen this in things like DSPy or other agentic frameworks, but having it baked into a single 20B model is new. Does this mean Chroma is moving away from being just a vector database and trying to become an AI infrastructure company?
I think they realize that a vector database on its own is becoming a commodity. Everyone has one now. Pinecone, Weaviate, even Postgres has pgvector. If you're Chroma, you have to move up the stack. By providing the intelligence that sits on top of the vectors, they make their ecosystem much stickier. If you're using Context1, you're almost certainly using it with ChromaDB, and that creates a very powerful integrated experience.
It's a smart move. It reminds me of how specialized hardware companies eventually start writing the software that runs on their chips because they're the only ones who know how to squeeze every last drop of performance out of them. Chroma knows how their indexes work better than anyone, so they're the best people to build the model that queries them.
And they're making it open source, or at least parts of it are accessible for research. That's a big contrast to the black box approach of some other companies. They want people to see the reasoning traces. They want people to understand why the model chose document A over document B. In high compliance industries like law or medicine, that explainability is huge. You can't just say, the AI said so. You need to see the path it took to get there.
So, looking at the second order effects, if this becomes the standard way we do retrieval, what happens to the frontier models? Do they just become even more specialized in reasoning and less about knowing things? We've already seen the shift toward reasoning models, like the O1 series. Does a world of specialized scouts like Context1 mean the big models can get smaller because they don't need to store all that world knowledge in their weights?
That's the dream, right? The infinite context versus perfect retrieval debate. If you have perfect retrieval, you don't need a 1,000,000 token context window. You just need the 10 tokens that actually matter for the specific question. It makes the whole system more efficient. It also means we can update the knowledge of the system by just updating the database without having to retrain the massive model. We've been saying that for years with RAG, but Context1 is the first time it feels like the retrieval side of the house is finally catching up to the generation side.
It's like we've had this incredibly powerful engine, the LLM, but we've been feeding it fuel through a tiny clogged straw. Context1 is like finally installing a high-flow fuel injector. The engine can finally run at full capacity because it's getting exactly what it needs, when it needs it.
And it changes the user experience of search entirely. Right now, when you search for something, you're the agent. You type a query, you look at the results, you realize they're not quite right, you refine your query, you click a few links. Context1 is doing that search behavior for you. It's an investigation engine. You give it the goal, and it does the legwork.
Which is why Daniel's question is so sharp. Is it an agent or a model? If it's doing behavior, it's an agent. If it's just processing text, it's a model. It seems like we're at the point where those two things are merging. A model that is trained specifically to perform a sequence of agentic actions is just an agent in a box.
It's agentic weights. I think we're going to see more of this. Specialized models for coding, specialized models for medical diagnosis, and now specialized models for search. The one model to rule them all era isn't ending, but it's definitely being supplemented by this hive mind of smaller, faster, cheaper experts.
I'm curious about the synthetic task generation they used for training. They used 8,000 synthetic tasks. That suggests they found a way to teach a model how to search by creating thousands of complex scenarios where a single search would fail. That's a really clever way to bootstrap intelligence for a narrow domain. You don't need millions of real-world user logs if you can simulate the frustration of a failed search and reward the model for finding a better path.
It's the AlphaGo approach, but for text retrieval. You set up the rules of the game, the database is the board, the query is the goal, and you let the system figure out the optimal moves to reach the goal. By doing it synthetically, they can cover edge cases that might not show up in a standard dataset. Things like, what if the information is split across two documents that use different terminology? Or what if the query is intentionally misleading?
It makes me wonder if we'll see Context1 for X in different industries, like a version specifically trained for GitHub repositories, where the search involves understanding code dependencies and call stacks, or a version for scientific papers that understands how to follow citations. Once you have the framework for an agentic search model, you can point it at any type of structured or semi-structured data.
Chroma is definitely positioning this as a platform. They aren't just releasing a model, they're releasing a blueprint for how they think the next generation of AI applications should be built. And for developers, the takeaway is clear. Stop trying to make your big models do everything. Start looking for the specialists.
It also makes the vector database dead meme look a bit silly. People were saying that once context windows got big enough, we wouldn't need databases anymore. But if you have a model like Context1 that can navigate petabytes of data by being smart about what it retrieves, the database becomes more valuable than ever. It's the difference between a library where you have to read every book and a library with a world-class librarian.
That's exactly it. The context window is the librarian's desk. It doesn't matter how big the desk is if the librarian can't find the right books to put on it. Context1 is the librarian. And frankly, I'd rather have a brilliant librarian and a small desk than a massive desk, and no one to help me find anything.
I think we should talk about the practical side for the people listening who are actually building this stuff. If I'm looking at my current RAG pipeline and wondering if I should switch to Context1, what's the litmus test? When is this overkill? And when is it a necessity?
The litmus test is your query complexity and your data heterogeneity. If your users are asking, what is our policy on X, and your data is a bunch of clearly labeled PDF manuals, Context1 is probably overkill. Standard semantic search will get you there 95% of the time. But if your users are asking, how has our policy on X changed over the last 3 years in response to new regulations in California, and which of our current projects are most at risk? That is a Context1 problem. That requires multi-hop reasoning, temporal understanding, and cross-referencing different datasets.
So it's about the hops. If the answer to a question requires connecting piece A to piece B to piece C, and those pieces aren't sitting right next to each other, you need an agent. If you're just doing a lookup, you don't.
And also the cost of being wrong. If you're building a customer support bot for a shoe store, maybe a hallucination isn't the end of the world. But if you're building a medical research tool or a financial analysis engine, the self-editing and ranking capabilities of Context1 provide a layer of safety and precision that you just can't get from a dumb retrieval step. It's about building trust into the system.
Speaking of building trust, what about the 25x cheaper claim? I'm always wary of those numbers because they usually compare a highly optimized narrow model to a general purpose model running at its most expensive tier. If I'm running a smaller version of Llama 3 or something, is Context1 still going to be significantly cheaper?
Probably not 25x, but likely still cheaper and more effective. The real comparison isn't just the cost per token, it's the cost per successful outcome. If you have to run a cheap dumb model 3 times to get a decent answer, or a massive model once, Context1 sits in that sweet spot where it gets the right answer on the first go because it did the internal work of the hops. It's optimizing for the end-to-end cost of a query.
It's like the difference between buying 10 cheap tools that break or one good tool that lasts. In the long run, the specialized, well-built thing is always the better value. And for businesses trying to scale these AI agents, reliability is the biggest hurdle to ROI. If Context1 can move the needle on reliability from 70% to 90%, that's where the real money is made.
I think we're going to see a lot of people experimenting with this in the next few months. Chroma has a huge community, and they've made it very easy to integrate. They're even talking about scalable synthetic task generation as a service, where you can generate custom training data for your specific domain to make Context1 even better at searching your specific types of documents.
That's the moat for companies. It's not just having the data, it's having a model that has been taught how to navigate your specific data. If you're a global logistics company, your data looks very different from a law firm's. Being able to fine-tune your Scout to understand the nuances of shipping manifests and customs codes is a massive competitive advantage.
It really is, and it brings us back to Daniel's question. It's a model that enables a new kind of agentic behavior. It's the missing link in the agentic stack. We've had the brains and the tools, but the eyes, the ability to actually see and find information in a complex environment, have been the weak point. Context1 is like giving the agent a pair of high-powered binoculars.
Or a metal detector. Or a drone. Pick your Scout-themed analogy, Herman, but the point is well taken. It's a specialized tool for a specialized task, and in the world of high-end AI, specialization is the name of the game right now. We're moving past the generalist honeymoon phase and into the industrialization phase, where we need things to actually work, consistently and cheaply.
I'm excited to see where they take it. They've hinted that this is only the first in a series of context models. We might see bigger ones for even more complex reasoning, or even smaller ones that can run entirely on edge devices. Imagine a Context1 class model running on your phone, searching through your private emails and documents without ever sending that data to a central server. That's the future of personal AI.
That would be a game changer for privacy. If the Scout stays on the device and only sends the highly filtered, relevant snippets to the cloud for the final general model to process, you're minimizing the data exposure significantly. It's a win for security and a win for latency.
It's a very bright future for the Humble Vector database. It turns out they weren't just storage buckets, they were the foundations for a new kind of active intelligence.
Well, I think we've thoroughly dissected this one. It's a model. It's an agent, it's a librarian with a very fast pair of shoes. Whatever you want to call it, it's a massive step forward for RAG. I'll be curious to see if the other database players follow suit, or if they try to partner with the big model providers instead.
My bet is everyone will have a search agent by the end of the year. But Chroma got there first, and their focus on the multi-hop reasoning trace gives them a significant lead in terms of technical depth.
Alright, let's wrap this up with some practical takeaways for the folks at home. If you're building AI systems, what should you be doing tomorrow morning?
First, evaluate your current RAG performance. Don't just look at, does it give an answer? Look at how many hops does a human need to take to verify that answer. If the answer is more than one, you have a multi-hop problem. Second, look into the Context1 API or the open source weights if you have the info to run it. Even if you don't switch over entirely, just seeing the reasoning traces it generates will give you a lot of insight into why your current retrieval might be failing.
And third, stop obsessing over your chunking strategy. If you're spending all your time figuring out if 500 or 600 tokens is the magic number, you're solving the wrong problem. Start thinking about how to make your retrieval more dynamic. Use a model to decide what it needs, rather than trying to guess what it might need ahead of time.
That's the big one. Move from static engineering to dynamic inference. It's a harder shift mentally, but it's where the industry is going.
Well, I think that's a wrap on Chroma's Context1. Thanks to Daniel for the prompt. He always manages to catch these announcements right as they're hitting the wire. And thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes.
And a big thanks to Modal for providing the GPU credits that power this show. They make it possible for us to dive deep into these models without breaking the bank.
This has been My Weird Prompts. If you're enjoying the show, a quick review on your podcast app helps us reach new listeners and keeps the algorithm happy.
You can find us at myweirdprompts.com for the full archive and all the ways to subscribe. See you in the next one.
Stay weird. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth.